Hi folks, welcome to my 8-Bit Retro Journal. It's a little different intro today. So I have this new smaller camera tripod which I can actually put on my desktop and have it facing right on the QL screen, which is kind of nice because it's not as cumbersome to be in the way, and I can do more QL stuff. I just don't have a screen capture for it, so by putting it right against this nice monitor really works well. So what I wanted to do today is actually show you how I used to do these compilations back before I even had disk drives, so just using microdrives. So I have, this is basically my development environment. I have QED, which is an editor that can, I can edit files with. So if I wanted to, for instance, start it up, I can double click it and then just load in, it's going to ask me for a file name, and I can just load in, I'll load in the command.h file, and again the vDrive does emulate microdrives, so it's not as fast as, and so this will load it in, and here we are. And yeah, this editor is really nice and works really well. And you know, you can do all sorts of things like move. If I want to move to the end, I can go move 125. Takes me to the end of the file. Right. So you have to understand the commands. There's a whole help system for that. But right now I'm not here to edit, so I'm just going to go and quit out of this. And so that was MDV3. If I go to MDV4, what you'll see is an empty microdrive. And then MDV5 will have the compiler. So in reality, I wouldn't have MDVs 3, 4, and 5. I'd have MDV1 and 2. So, but I'd be using 3 microdrives to do that. So this is empty, and then MDV5. And so the way I would do this is I would, the first thing I would do is I would have a blank MDV, which is this, and I would copy some stuff onto that from the other two microdrives that I would need eventually to create this stuff. And I would have enough room to do that generally with what I was doing. So let me do that first. And the nice thing about using ICE is that it lets you do these copies pretty easily, right? So the things that I want to have on there would be stdio, stdlib, and they weren't very big, and mcobj, and those are the 3 files I would need on MD. So you can't see this right now because again the screen is cut off, but to get to MD4 I just have to hit the button once and then hit it once, and this is going to ask me if I want to copy 3 files. It'll actually copy it to me in the order that I selected too, which is nice. And so that gives me a little less typing than I'd have to do in the command line. Again, I don't have Toolkit 2 installed because it takes extra memory, and so I would actually have to type each of the copies, and there's no wildcarding in the original QDOS, so it would take a little bit more time. And so this is copying the 3 files over to the blank, and then I would have to then copy the sources to the blank. And I'll also show you how to configure both CC and CG. You can see that there's a config program which configures it to basically then use the workbench basically, and so you can basically point it to. So I would have had them point to MDV1. In this case, they're going to be pointing to MDV4. So I am using 3 microdrives, but I'm only going to use the MDV3, which the original source is, only for copying, and once I've copied them over, I will not need them. In fact, what I'll have to do at one point is actually delete them, the sources, from my working directory, because when I am ready to link the objects together, I won't have enough space. Again, 128K are the microdrives, but it was doable to create this on the microdrives only. So now what I want to do is, so this is pointing to MDV4. I got to go one more, and then double click on that. That gives me back my sources. and I'm going to choose the header file and the three C files, and I'm going to move them to MDV4. Configure the compiler and the linker, the code generator, right? So now I just want to copy these things over. So again, I'm going to select this, this, and this, and copy them over to MDV4. Again, just a single, and click that once. And that's going to copy those, and that's going to fill up nicely. But again, most of those files, the source files are bigger, but I'll have plenty of room for the three object files that I'm going to generate, which is an object file for command, for expression, EXPR, and for auxiliary, AUX. And then, so that's usually how I had it set up. I had sort of a source microdrive with QED and all my sources on there. I had a sort of a workbench microdrive that was blank that I set up, copied those things over. You made sure that was a good microdrive, freshly formatted, and then my digital C was configured to work off of that workbench. And usually the workbench microdrive would sit in MDV1, and I'd stick the source in MDV2 and copy everything over. I'd stick the digital C in MDV2 and copy everything over, and have it configured to deal with MDV1. And so it wasn't that much of a rigmarole. You really just had to keep the workbench MDV in MDV1 and microdrive in MDV1, and then you would just pop the source in MDV1 and copy all the sources over, and then finally put the digital C compiler in MDV2, and you were ready to go. Because I didn't have to. So what I'm going to do after this is done is I'm going to reconfigure digital C, but I would have only had to do that one time, the very first time, with my working digital C microdrive. Again, this is taking a while because my virtual microdrives, vDrive, does emulate them, and so every bit of data it has to copy and sector seeks and everything is done at the original microdrive speed. The only benefit you get from this is that they don't fail, right? So you don't have that. So this is like the ideal microdrive life where, yeah, they're going gangbusters, but of course, in reality, when you heard the microdrive whir after about 12, whatever it was, 16 seconds, a quarter of a minute, you knew something was up, and potentially you would sit there for longer. But that was the life with microdrives. Again, I didn't have that happen too often, and I was very cautious with that. So if I double click now, this is on microdrive 4. This will show you what's on microdrive 4 and what I've set up. I'll have the three things that come from digital C, and then the 4 files. So I should have 7 files on microdrive 4, and then I'll just have to, so I have stdio, sdlib, mcobj, and then the 4 files, and still have plenty of room. I have about 59K, and the object files combined are not going to be 59K, so they're just going to fill it up nicely. However, then when I'm ready to link, I'm going to have to actually, the reason I have it set up this way is because, and I'm going to go to MDV5, because I'm going to have to delete all the sources in order to link it together to have room for the final executable. So that's why you need that workbench one, because the source files are only going to sit there temporarily, and then once you've got them compiled, then you're going to get rid of them and to make room for linking the object file into the final executable. Okay, so the thing I need to do here is run this config program, and it's going to basically change this, so you could organize the screen any way you want, which is kind of convenient. But so I want MDV5 CC. I want to use, again, this way I would put MDV1. I'm going to use MDV4 today for MDV1. I think I had this at 130, which works for the US system, and everything else stays the same. Screen's fine. It's funny, it's going to ask me for another file. As soon as it does, it's just going to reset its own internal screen in the config program. So you can config the config program using the config program. But if I say more files on, you'll see that it's going to reset itself. So that's the default, using the whole screen. But that's okay. MDV5 CG, which is a code generator. and that's also going to use MDV4. And again, 130 for this, and everything else is default. And yes, that's fine. And no, I'm done. That's going to take me back. So the first thing then, so I'm ready to go. It's configured these programs. No, I'm going to go back to ICE. And I'm going to stay in ICE for a little bit. It's not necessary. I can do this from the command line, but I am in MDV5, so I can just double click on it. And then from there, I just basically have to run the compiler 3 times for each of the source modes, and then link it. And so I would probably start the compilation and just either stop the recording or probably stop the recording, just because even though doing fast forwards might be nice, I think it just might fill up my camera. We'll see how it goes. But let me start this one up. I'm not running it, if I run it on the command line, I can run it in the background, but I don't have enough memory to do anything anyway. So here I'm going to, so I actually don't even have to say MDV4 because it's the default. So all I have to really say is CMD C and M and P for more and pause, and this should actually then run and start the compile. Wow, that actually only took about 3 minutes, which is actually pretty fast. I know you might laugh at that and go, 3 minutes, are you kidding me? But yeah, it's microdrives. I think when you, and it's probably one reason I did this, when you copy files over, the QDOS internally caches them, and it keeps it around and only removes the parts of that cache when it needs it for other things. So sometimes you can get a little bit of a speed up if you do a copy right before you then utilize that copy. So in other words, if you copy something, I'm going to do the CC again. If you copy something to the console to see if it's okay, and then you copy it to another MDV, it goes much faster. Or if you copy to the console a second time to list it again, it'll just zoom by because it has it in an internal cache. So this time, it's going to be the expression, and again, more, which basically just lists verbosely the function names. And I'll let it run because I'm only I stopped and started the video when the other compiled, and I was only I'm only 4.5 minutes into it. If these chunks get longer than 15 minutes, it just takes up. I use an iPhone, and it just becomes problematic if they become bigger than 2 GB videos because my Windows can't see it. Then you have to use iTunes, and it's just kind of a pain. So I had to keep my video chunks off of the iPhone as small as possible. I guess I need to research whether or not I could. I mean, I assume you can only save it in movie format. But by the way, the reason it doesn't show, I believe, any function names initially is because it's reading in the header file, and sort of creating an internal representation of that. And then once it has that, it starts. So my header file is pretty robust in that I do a lot of defines for various things because it's a nice way to make C look a little nicer. Like for instance, I do a define on ADDR for address as a substitute for a long integer, long, and that that just makes the code read better. That this is an address that you're saving, etc. But yeah, it's going pretty quickly. So again, some of this must be. These are shorter functions, but I was surprised with the first one that parse basic, which is really a huge function that has all this switch statements in there. It really went very quickly. I expect this all to compile without error. I haven't modified it. It's actually, if you watch my first Macintosh video on I think it was March 6th, on the command shell and scripting language, I showed you the source files that I'd copied over. These are those source files. And then I modified them to make them work on the Mac and added some hooks. But and then of course the eventual version of Climax worked just nicely. But yeah, this is going along at a nice pace, believe it or not. I know that sounds odd, what I'm going to do moving forward, and I'm not going to do this every week, obviously I think people will get tired of watching me compile, but I actually do want to do some real live coding, and specifically finishing my ZX simulator, which is based off of this source, but has an additional fourth file. I mean, right now, because I couldn't figure out how to, I finally figured out again how I can compile things in multiple files. For ZX simulator, actually, I concatenated it all into one single file. Which works well on emulators because you know, they have enough memory and they go fast enough. But when you're working with microdrives, it's actually better to have it the way C has intended, that you have individual source modules and compile them only when needed. And that actually speeds things up. So when I'm changing something in command and it's not hitting the expression tree, well, there's no need for me to then do anything about that. So I might get this all in one chunk here, so that would be great. So I'm going to run this. But yeah, when I did ZX Simulator, if you can go to the QL forum and get the source for it. It's just one large source file, but I can split it back up into the three constituent CMD, EXPR, AUX auxiliary. So again, here this is going to be AUXC more, oops, and pause. And I can add I think the graph for graphics, specifically for the ZX81 graphics. So that'll be the fourth module. And the nice thing is, whenever you don't always have to recompile everything if you're not making any fundamental changes, especially if the header file doesn't get changed and it's just a bug fix. And so that also improves. So if you're seeing this being compiled in live in real time, the reality is, as you're compiling it, that you don't have to compile all three for this prototype or all four for ZX Simulator. You only compile what you're focusing on. Now, not always true. I think one of the things I need to do is add floating point to the ZX Simulator. I think that's going to hit a lot of, that might cause me to have to recompile everything, because it's going to change a few things fundamentally, but that'll probably be a multi-part video. But yeah, I during the pandemic when I started this, I kind of used emulators a lot. And as I've started doing my videos, I kind of realized how much I enjoy using the QL. And I wanted to get a video card that could use my SCART cable. And I bought something and it was broken. And because of COVID, I hadn't decided to buy it again because it was kind of a pain to try to get a refund. But yeah, no, this monitor is doing a pretty decent job with my. I mean, so I did again. You can go back and figure which video I did this in, but I did a hack on the QL to get color composite out. And if you know the QL, you might go like they have color composite by default. You just have to get the right pin. Well, the US versions don't. They give you RGB, RF, and monochrome composite, but not color. So I had to actually, and it's an easy fix. It's like in the ZX Spectrum, you just grab it off of the RF modulator, and it's giving a beautiful signal here. I mean, it's a little shimmery, but still, I mean, it's if you're doing stipple patterns, and I don't know if you can tell, I'm looking through the camera, and I can't really see it, but there's lots of shimmery stuff going on right in this area. With the red, it's like a little bit of a green shadow, but the white on black looks nice and crisp. Again, I could put this in monochrome mode, and it would look. It's almost, when I put it in monochrome mode, it reminds me of the original Kindle Reader that was just a black and white screen that was as crisp as possible. So monochrome composite doesn't have all that interference. But yeah, so I've kind of pushed back. I think this is a pretty good monitor, Supersonic, that gives you this really nice picture with not that much interference. So I've been happy with it. And so yeah, I haven't really done anything in terms of spend money to get a converter. Now, again, I'm hunting for an Amiga 600. It's been difficult to find one with US NTSC video. And you might go, well, who cares? You're not going to use it. I did some cool stuff with the QL and its RF signal, like creating a transmitter. And so I kind of want to have that ability on the Amiga, even though, yes, I probably used to use its RGB signal. I mean, you want to do an Amiga justice by using its full capabilities. The QL, yeah, if I had a working SCART cable and a converter, it would be much better. But still, I've been happy with this monitor and this composite color. It has those artifacts that you have. Okay, wow, we're done. All right, so next, we get to actually go on MDV4, the thing we've compiled on, and you're going to get to see. Again, we're only at the 12-minute mark, so yeah, this video totally is only about 22 minutes long. Again, I stopped it and started it again for the because I didn't want to. I didn't know how long this was going to take to run, but my whole point is just to create an executable. So all I have left to do is delete the source files off of this one, right? Which has now, you can see it has all these object files that I've created. Very, just like, I mean, I don't want to keep saying very Unix-like. It's like any. It's like any other compiler, but it just reminds me very much of Unix. Anyway, I don't need any of these. I don't need the standard I/O. I can keep it. It's really not that big. I think I have to escape, but I'm going to just delete all the source files, so I don't. Oops. So that's how you undo it. But I can get rid of this one, which is not very big, but this one's big, and this one's big, and this one's big. And so to delete them, it's like a video game. I know. I should use my... I haven't worked on my fancy new mouse yet, so I'm using my... hoping that... Okay, deleting those files, and yeah, we're good to go. So now we just go... we have enough space, 129, and we have the 3 object files. So now go back to the MDV5, we're going to run the code generator, and we're so close to being done. So it might take less than half an hour to recompile, but yeah, it's not bad. I know that I posted once on the QL forum that it took a long time to compile ZXsimulator, but then again, I had it in one big file, so I'm wondering if I split it up, that you can make it pretty manageable. This is pretty manageable. I mean, I know we're all spoiled with... Okay, so for the command line, what we want for the code generator is the first argument is going to be the name of the program it's going to compile to, so CL, and then the 3 object files, so CMD, OBJ, and I could leave the OBJs out, but it just makes it clear. The expression tree OBJ, and then the auxiliary file OBJ, and then we have to add -NC for no command line. And the reason why is the command line that Digital C gives you right here, it also puts on every program because it kind of wants to be C-like, so that you get a command line that you can pass arguments in. Obviously, it allows you to add graphical stuff, and as you saw in my ZXsimulator, you can write full-fledged programs. But similar to how the Macintosh, if you saw my Macintosh videos, Think C gives you a console window. They here try to give you sort of an entry window to allow you to pass arguments. So I think it's pretty cool. Although if you do NC, you can still see it create the window and remove it really quickly, so you can kind of flash. And I haven't figured out a way to get rid of that yet, so that's kind of disappointing. I'm sure there's a way. I've read on QL forum there's a way. I tried some of those. It hasn't worked for me, but I'm sure there's got to be a way to have complete control over the windowing that it creates and remove it. But the code generator usually is pretty fast because it is trying to. It's basically just taking those 3 object files, throwing them together. If there's any relocatable stuff, it has to worry about that, and then it throws a header on there, I think, and that's about it. So we should be done pretty quickly here, and we'll have our executable. So that's the process that I used back in the day, and it worked pretty well. And again, the nice thing is if you're just changing one place, you really only have to compile that. So you turn this into a very practical way of coding. And again, this is going at the speed of microdrives. Even though you have the reliability of the emulated microdrives, it's still at that speed, so it doesn't change. It's not going faster because I'm using an SD card. Now there are, when I had a floppy, things would go faster, and when if I get the SD, there's going to be a ROM version for the SD reader that you can put in the back. The problem is then I can't run ICE, so there is an internal version that I could get, but maybe I'll do that someday. There is you can get a micro card version of that, so that it comes out of the back of the QL, so you can keep your 2 microdrives. For whatever reason, I like to keep the 2 microdrives. So it's just right now hitting the vDrive, and linking it all together. So it's just writing I think it's about 40K in size file. So that is going to take a little bit of time. Once I update my vDrive, I think what I'm going to do, I have that little board that you can put in the vDrive to give you the whirring sound of the microdrives, and I think if I had added that in, what you'd hear right now is that sound, because the red light's on, meaning the vDrive is being hit, meaning that the microdrives are being hit. So something's being written sector by sector. But once that part's done, we'll have an executable. So I don't think I should have to fast forward over this, but we'll sit here and wait. Usually this part's fast. All right, there we go. So if I go and go to MDV4, where we actually stuck that to, we are going to get, we should get CL, there it is. And so there's my compiled executable. And if I double click that, I should get freshly compiled on the QL. It just wrote it. Okay, we're there. So here it is running. So let me do a version on this. Yeah, version 1. So I'm going to end here by writing the most famous program that we all wrote as kids. Oops. Excitedly, right? And then 20, go to 10, and let's run it. And there it is running. This was the prototype command shell for the Mac that I demoed in March 6th for Macintosh, and I've recompiled it here on the QL using Digital C, and it's running. So just wanted to share with you how I did development back in the early 90s with a mid 80s computer. Not too much different. I do a lot of C programming on a Linux machine, and yeah, it has a similar feel, which is why I like it. But so yeah, I'm going to end it here, and thanks for joining me today in my journal entry, and I hope to see you soon. Stay safe.